Alright, in this lesson we will convert polar equations into rectangular equations. We already have these formulas, and we're going to use those today. But what if we had something like this, a polar equation, r equals 5, and we're trying to replace r with something? We can't replace it with this r, because then we'd have a y in it. We'd have a theta still in it. So we have to be creative here, and in this case we would square both sides to get r squared equals 25. Now we have something to substitute for r squared, which is x squared plus y squared, and that's how we would convert this polar equation into that rectangular equation. Alright, so theta equals pi over 6. What could we use? Well, that's not going to work very well. But over here we have tan theta equals y over x. So we could just have tan theta equals tan pi over 6. And now we know that tan theta is y over x. And we have y over x equals, and we just have to evaluate tan pi over 6. And there's pi over 6 with a 1, 2, radical 3. So this is going to be 1 over radical 3. And then we'll write y equals, write this as 3, radical 3 over 3 times x. So there's the rectangular form. And you try this one. Pause the video. Actually, try both of these, because I went over one like this already. So pause the video and do both of these. So tangent is radical 3 over 1, and y equals radical 3 times x. If we square both sides, then we have r squared is equal to x squared plus y squared. And now we have the equation of a circle. And in these equations, we can't square both sides to get r squared, because then we'd have cosine squared, which we don't have a formula for. So the strategy here is we will multiply both sides by r. Now we have r squared, and we have r cosine theta. So that's important to be able to substitute for. And r squared is x squared plus y squared. R cosine theta equals x. And we could just write this as that rectangular form. Pause the video and try that one. Multiplied by r. R cosine theta is x. convert these into rectangular form, and we have a, well, we could just do cotan theta equals x over y. If we were really focused only on the formula that we started with, we might say, okay, that could be 1 over tangent, but cotangent is just x over y, so we could just do x over y equals -3, and x over -3 equals y. And you try this one. Pause the video. Tangent is y over x, so y equals 2x. Well, we need to see r cosine theta and r sine theta in order to substitute for these. So if we multiply both sides by this denominator, we will distribute the r, and we'll get r cosine theta and r sine theta. So let's multiply both sides by the denominator. And that means when we distribute r, we'll have r cosine theta plus r sine theta equals 1. R cosine theta plus r sine theta equals 1. We could write it like that. All right. And I think I'll get you started on the next one, then you can finish it. And when you have pi over 2, you want to think of the cofunction identities. So we're looking for cosecant pi over 2 minus theta. And we don't have that yet, so we need to rearrange that. And you can switch the order of subtraction by factoring out a negative sign. Not only do we need the cofunction identity, but now we need to know the even or odd functions. So there's only 2 even functions, secant and cosine, so this must be an odd function. That means that negative can go on the outside. Now we have, we'll use the cofunction, and that is all right. And you try it from there. Pause the video. And we don't have a formula for secant to replace secant with anything, so we would rewrite that as 1 over cosine. If you multiply both sides by cosine, now we have r cosine theta, and r cosine theta is x. Okay, now we don't have pi over 2. We can't do the same strategy with a cofunction identity. It looks like we're going to have to use a difference formula. We don't want to work with secant, so let's write it as cosine Alright, and then we have to remember that cosine changes signs, changes the operation. We need to evaluate 4 pi over 3, and this is 3 pi over 3, so 4 pi over 3 is there. 4 pi over 3, and that'll give us a 1, 2, radical 3. Cosine of 4 pi over 3 is negative 1 over 2. And sine is negative radical 3 over 2. And then when we multiply both sides by the denominator, then we'll get the r times each of these. So we have negative 1/2 r cosine theta minus radical 3 over 2 r sine theta. Our cosine theta is x, y. So we have an equation there. And I guess put it in standard form, we could multiply by negative 2. All right. And one more. All right, convert that to rectangular form. Pause the video. So now we need to use the sum formula for sine. Sine, cosine, cosine, sine. And we have the same operation. We're evaluating pi over 3. So that's the triangle for pi over 3. Cosine of pi over 3, 1/2. And sine of pi over 3, radical 3 over 2. But we don't have r sine theta. We can't multiply by sine. We'd have to divide here. That's not going to help. And here's where we want to multiply both sides by r. We'll distribute r in there. Let's go ahead and distribute the 2 also. So 2 times 1/2 is 1. Then times r, and we get r sine theta. 2 times radical 3 over 2 is radical 3 times r, and we get radical 3 r cosine theta. R squared is x squared plus y squared. R sine theta is y. R cosine theta is x. And we can put it in general form. And that's the last example.